Professor Dave and Chegg here. A very important topic is solution chemistry, as most of the chemistry we are discussing occurs in a solution of some kind. So it will be very important to start out by understanding what a solution is. And to understand what a solution is, we must understand the process of dissolution, which is when one thing dissolves in something else. Let's learn precisely what that means.
Many substances, when placed in some solvent, will dissolve, yielding a solution. In a solution, there is a solute, which is the thing that has dissolved, and a solvent, the thing that the other thing was dissolved in. And the solvent is typically present in a much greater amount. If this solvent is water, then we would call this an aqueous solution, from the Latin word for water, aqua. So any solute that dissolves in water will produce an aqueous solution. We will measure the concentration of a solution in terms of molarity, which is symbolized by a capital M. This refers to the moles of a particular solute that are present per liter of solution. We should be able to calculate the molarity of any substance given the moles of that substance and the total volume of the solution. For example, let's say that a 355 milliliter soft drink contains 0.133 moles of sucrose, or table sugar. What is the molar concentration of sugar in the soft drink? Well, as we said, molarity is defined as moles solute per liter of solution, so let's plug the numbers in. 0.133 moles goes on the top because that's how much solute we have. And as for the volume of the solution, this must be in liters. So let's convert our 355 milliliters into 0.355 liters and put that on the bottom. Doing the math, we should get 0.375 molar as the concentration of sugar in the drink. This kind of information is useful because we could then calculate the amount of sugar that would be in any volume of the soft drink, or the volume of soft drink that would be required to provide a particular amount of sugar. Now, we can also rearrange the variables in this equation to be able to calculate other quantities. Let's say we multiply both sides by liters. That would mean that the molarity of the solution times the volume of the solution would give us the moles of solute in the solution, which could be useful information. We could then divide both sides by molarity, which would mean that the volume of the solution would be equal to the moles of solute divided by the concentration of the solution, which could also be useful information. Let's try using both of these equations. Let's revisit our favorite soft drink that was 0.375 molar in sugar concentration. What if we wanted to know how much sugar there was in a standard sip, which is about 10 milliliters? Well, let's use this modified version of the equation. The moles of sugar will be equal to the concentration, 0.375 moles per liter, times the volume, which when converted into liters will be 0.01 liters. That will give us approximately 0.004 moles of sugar for every sip, which we could then convert into mass or even number of molecules if we wanted to. Let's say instead that we wanted to know what volume of the beverage we would have to consume in order to ingest 1 mole of sugar. We could use the other modified version of the equation over here. The total volume will be equal to the moles of solute, 1 in this case, divided by the concentration of that solute, or 0.375 moles per liter. Moles divided by moles per liter will give us an answer in liters. So doing the math, we get 2.67 liters. This is the volume of soda you would have to drink in order to consume 1 mole of sugar molecules.
We now understand molarity as the unit of measurement describing the concentration of a particular solute within a solution. But we can also modify the concentration of a solution by a process called dilution, and we will have to be able to perform simple calculations involving dilution. So let's learn how to do these as well.
Say you have a glass of lemonade with ice in it. As the ice melts, water is being added to the solution, thereby increasing the volume and diluting the concentration of the solute that gives the lemonade its flavor, which is why the lemonade will have a weaker flavor as more ice melts. So dilution refers to the process by which the concentration of a solute is diminished as additional solvent is added to a solution. We use dilution in the laboratory as well. Sometimes when we do chemistry in the lab, if we want to use certain chemicals that exist in the liquid form, we might get them from a concentrated stock solution. This is where it is stored at a very high concentration, from which we will then take a small quantity and bring it to the desired concentration by dilution. To perform a dilution, we will add additional solvent to a small amount of concentrated stock solution until the concentration is reduced to the value we desire for whatever experiment we might be doing. During dilution, we are not changing the amount of solute in solution. We are only changing the volume of the solution, and thereby its concentration. We can relate the concentration and volume of a solution before and after the dilution by the following equation: M1V1 equals M2V2. The subscript 1 is referring to the solution prior to dilution, and the subscript 2 is referring to the solution after the dilution. If we know any three of these values, we will be able to calculate the unknown value. For example, let's say we have 0.850 liters of a 5 molar copper nitrate solution. We dilute this solution with water until we have 1.80 liters of solution. What will be the concentration of the final solution? Well, let's plug our known values into the equation. We know the initial concentration and volume, which become our M1 and V1, and we also know the final volume, V2. That means we want to solve for M2. Dividing both sides by V2, we get M1 V1 over V2 equals M2. Now we can plug in all of our values, do the arithmetic, and we get 2.36 molar as the final concentration of the copper nitrate solution. So we can use this equation to solve for the final concentration of a diluted solution, but more often than this, we will need to solve for the final volume of a diluted solution. This is because we will very frequently need to create a stock solution of a particular concentration to be used in an experiment. So we will need to know what volume to dilute the stock solution to in order to get a solution of the desired concentration. For example, let's say we have 11 milliliters of a 0.45 molar hydrobromic acid solution, but the experiment we are doing calls for 0.12 molar hydrobromic acid. What volume must we dilute this solution to in order to get a solution of the desired concentration? Just as we did before, we will rearrange this equation to solve for the unknown variable, in this case V2. Dividing both sides by M2 will give us M1V1 over M2 equals V2. Now we just plug in the numbers we know for the initial concentration and volume, as well as the final desired concentration. Doing the arithmetic, we get 41 milliliters as a final volume.
With that, we now know how to calculate the concentration of a solution by finding its molarity, as well as performing dilution calculations, which involve reducing the concentration of a solution. Professor Dave for Chegg. See you next time.